Hey guys, this is Mr. Morgan with your Week 1 Check-In with Teacher Conference. Please review this video prior to speaking with me, and we will talk about the questions from the video. So just a little review. If we are given, we're going to look at finding constant and proportionality in different scenarios given different information. So if you're given a graph and you have to find the constant and proportionality, really what we're looking at is this unit rate. We're looking at the factor by which the x variable is being multiplied in order to get the y variable. We're trying to explain that relationship between those two numbers. So here we have 1 is paired with 8, we have 2 is paired with 10, 12, 14, 16. So it appears that the y is 8 times bigger than the 1 each time. So if we take our y divided by our x, 8 divided by 1, or 16 divided by 2, that gives us 8. That's the constant of proportionality. So on a graph, visibly, it's easy to identify that constant of proportionality because you're looking for that unit rate. Also, like in terms of words or expressions, in this case we have Paul earned $46 in 10 hours. So we can find essentially the unit rate, which will be the constant proportionality, by dividing the dependent variable by the independent variable. So how do I know the $46 is the dependent variable? You have to ask yourself is which depends on which. Does the money Paul earns depend upon the number of hours he works, or does the number of hours he works depend upon the amount of money he earns? Well, it seems to me that the more he works, the more money he will earn, so that makes this 10 hours the independent variable and the 46 the dependent variable. So I would divide 46 by 10 to get our constant of proportionality. A couple other scenarios. In this case, the library charged Monica 50 cents for a book that was 10 days overdue. So in this, I identified the variables, the days overdue, and the cost. I identified the independent variable as the number of days because the cost of the fee, the penalty, is dependent upon the number of days that the book is overdue. More days overdue, higher cost. So the independent variable is the number of days, and the dependent variable is the total cost. Now if I were to divide this out, 10 days, 50 cents, to go from 10 days to 1 day, I would divide by 10. So likewise, if I divided 50 cents by 10, that's going to give me this 5 cents, or a nickel a day. So then I composed this table organizing some equivalent information. If 10 days is 50 cents, then 8 days would be 40 cents, 6 days 30, 4 days 20, and 2 days 10 cents. I could go down to the 1. To go from 2 to 1, I would divide by 2, so likewise 10 divided by 2 would be 5 cents. That's where that unit rate comes from. Okay, so in the graph, I noticed a few things. Since this is a proportional relationship, let me briefly talk about the table real quick. I know this is proportional because I am multiplying the same factor times the independent variable to get the dependent variable. 2 times 5 cents, 4 times 5 cents, 6 times 5 cents, 8 times 5 cents. So because it's that common factor every time, that's going to be proportional. Also, this is increasing the same as well, which would make it appear proportional, but we have to take into another consideration, which I think that the graph illustrates that. For it to be proportional, it has to start at the origin. Okay, 0, 0 has to be a point on the line. Okay, so if there were 0 days, of the book being late, then there's going to be 0 cost for Monica. So that is a point in this situation. Starting at the origin and then a straight line makes this proportional. No curves, no zigzags or anything like that. This straight line indicates a constant rate of change. And that constant rate of change can be identified as this constant of proportionality. And then with an equation, I know this is proportional because the x variable, the independent variable, is being multiplied by the same constant in proportionality. Okay, nothing else is happening except for this single operation, multiplication. If I were to add something to this expression, then this no longer becomes proportional, because in adding something, it's actually going to move this line up. Say we added 10 cents. So that means that at 0 days late, Monica would still have to pay 10 cents. So this line would start here at the 10 cents, which would not be proportional. Okay, so this is proportional. I can look at the equation. I know it's proportional because there's no other operation except for multiplication. At the same time, this could be division, because we know that multiplication and division are inverse operations. I could rewrite division as multiplication. Divided by 2 is the same thing as times 1/2. So that's how you know this is proportional. And then, of course, just a little summary. This is the constant proportionality is 5 cents, and that's the number that's being multiplied times the independent variable. All right, so now I'm going to pose 3 questions. We're going to talk about these in your conference today, or whenever I do speak with you. Just be prepared to answer these questions, okay? And if you need to pause the video to look at the questions longer, that will be wise. So real simply, the same information I just gave you, I just need you to reiterate, how do I know that this situation exhibited in the table is proportional? How do I know this is this relationship between days and costs is a proportional relationship? That's question 1. Question 2. According to the graph, how do I know this represents a proportional relationship? And then number 3, according to the equation, how do I know that equation represents a proportional relationship? Be prepared to answer those 3 questions when we speak. All right, I look forward to talking with you, and you guys enjoy the rest of your day and your weekend. If that's all you have left to do is the teacher check-in, and I look forward to talking to you again next week.